right, I'm going to go ahead and get started since it's 10 o'clock. If you looked ahead, you did, I usually tell you ahead of time, but you did, there is a test this Sunday. Your assignments this week are the review for test 3, which we're going to start today, finish on Wednesday, and then one more section in, I think, chapter 9 that we're going to do on Friday. So you do have a test that's due Sunday at midnight. So again, we're going to review for it today and Wednesday. We'll get through the first 15 today. That'll just leave us with 10 problems to do on Wednesday. Okay, the first problem goes all the way back to the beginning of this, what we were talking about. And what we first started talking about was end behavior of graphs. Okay, so the end behavior comes from the leading term of the polynomial. So we're going to, is that review? So when you're talking about end behavior, you're always going to search out the leading term of the polynomial. So let's look at number 1. So the leading term of a polynomial is not necessarily the first term. It is on this one, but it's the term that has the highest exponent. So let's find that term first. So if I'm looking at all these terms, the one that has the highest exponent is coincidentally the first term. So there's your leading term. That's what's going to tell you what's happening at either end of the graph. If you put this into your calculator and graphed it, what will be happening at either end? So there's 4 different kinds of end behavior. The 2 things that determine your end behavior are whether or not your exponent is even or odd. So even means that your end behavior is going to be doing the same thing on both ends of your graph. So they're either both going to be going up or they're both going to be going down. That's what end behavior even is. If it happens to be odd, that means the end of your graphs are going to be doing 2 different things. One side will be going up and one side will be going down. So let's see, it's either going to start down, do some stuff in the middle, and end up, or it's going to do the opposite of that. It's going to start going up, do some stuff in the middle, but end up going down. Oh, let me get my chair out of the way. So that's the difference. They're either both up, both down, or starts down, goes up, or the last one starts up and goes down. So since this one is even, it's one of these. So then to decide which one it is, then you look at the sign of that leading term. If the sign of it is is negative, that's what flips the graph upside down, right? That's what turns. We looked at a lot of those when we were doing x squared graphs. If the x squared was negative, it flipped it upside down. So if you're negative and even, your end behavior is going to both be down. So that's what this one is. Both downs. Let's look at number 2. I'm going to leave all our options up here. It's the same kind of question. It's still an end behavior question, but it's going to have a different end behavior. F of x equals negative 3.1 x to the 4th plus x to the 6th plus 0.2 x to the 7th. So again, remember the first thing you want to do is search out your leading term, not the first term, not the term in the front, the term with the highest exponent. So our leading term is actually this one, right? It's the one that has the highest exponent of 7. So that's the term that is going to determine your end behavior. So this time, since your exponent is odd, it's one of these end behaviors. Odd exponent end behavior is telling you your ends of your graphs are doing something different. One up and one down. So now we decide if it's positive, it's going to do this one. It's going to start down, but it's going to go up throughout the graph. This is what it would be if it was negative. It would be start at the top, but travel down throughout the graph. So is this one positive or negative? It's positive, which means it starts at the bottom and travels up. So it's this one right here, which looks like C in your multiple choice there. All right, number 3, f of x equals x squared minus 16 to the 4th power. And this one wants me to find the zeros of this function and then state the multiplicity of each. So to find zeros, let's see. When I'm looking inside that parentheses, I can tell that it's not all the way factored. I do need to factor it, set my factors equal to 0 and solve them for x to get the 2 zeros, or what kind of factor is this? It's an x squared, which means I can also go to my quad program, right? That'll help me also find zeros when I'm dealing with x squareds. Okay, so I can go to my quad program and put in the a, b, and c, or I can just factor this. It's not a hard factoring problem. It's difference of perfect squares. X and x for x squared. The factors of 16 that are the same, which means if I put them together, they would cancel each other out, which would be 4s, 1 positive and 1 negative. So there's the 2 factors. If I set those factors equal to 0, and solve them for x. So let's see, that x plus 4 factor, if I solve it for x by subtracting the 4 from both sides, I would get x equals -4. If I solve this one for x by adding the 4 to both sides, I would get x equals +4. So there's your 2 zeros. Positive and -4 are the 2 zeros. What is the multiplicity? Where does that answer come from? Your multiplicity is whatever the exponent is over that factor that gave you those zeros. So positive and -4 are the zeros, and the multiplicity of each of those would be 4. They each have a multiplicity of 4. Number 4, find the zeros and state the multiplicity of each. So let's see, the function is f of x equals -7, x minus 5 to the 4th, x plus 2 to the 3rd, and x to the 2nd. So first of all, let's list all of the zeros. Remember, your zeros come from each of the factors that has an x. So let's see. This doesn't have an x, so it doesn't make a zero. going to give me a 0. What about this one? X plus 2, I'll set that equal to 0 to find its 0 that comes from that factor. And this last factor is just an x. So I'll set it equal to 0 to find its 0. So this is going to have 3 separate zeros, which are the x-intercepts of this graph. So let's see what this one is. I would have to add the 5. So that 0 is going to be x equals 5. So it's going to have an x-intercept at 5. Get rid of the plus 2 with a minus 2. So x equals negative 2. And then this one's already solved, right? X equals 0. It's already solved. So 5, negative 2, and 0 are the zeros. Let's look at each one's multiplicity. What does the multiplicity come from? It comes from the exponent of the factor where the 0 came from. So what's this one's multiplicity? 4. So that one's multiplicity is 4. The negative 2 zeros multiplicity is 3. And then the last one, the zeros multiplicity is 2. All right, number 5. This time it's going to ask us to find the zeros and the multiplicity of each, but it's not going to give us the factors all factored out, all nice and neat like that one did. It's going to give us the whole list of the polynomial function, and we're going to need to factor it ourselves to get the factors to be able to get the zeros. So we have x cubed minus 4x squared minus x plus 4. So like I said, we're going to do the factoring ourselves. Remember what zeros are. They're also called x-intercepts. So if you went to y equals, let's try that. I'm going to do it both ways. So if I go to my y equals and put this in as my function, let's see, x to the third minus 4x squared minus x plus 4. So there's my function. Excuse me. If I graph that, remember what zeros are. They're x-intercepts. So I see 3 times that this graph crosses the x-axis, and it looks to me as if they each cross it at good spots. Look right here. They cross at good hash marks, not in between 2 hash marks. So it looks like it crosses where? It looks like at -1, +1, and +4. To be sure, I can go to my table, and at each one of those x's, -1, +1, and +4, the y value for each of those should be 0, right? That's what makes you an x-intercept, is that your y value is 0. So if I hit second table and go to those 3 x-intercepts, or what I assume are x-intercepts. One I said was at -1. Well, it truly is. It is a 0 because its y value is 0. +1 is a true x-intercept, but what about 4? And so is 4. So those are going to be the 3 x-intercepts, which is the most it can have, right? Because the most it can have is whatever that highest exponent is. But, so what did I say? So they should be -1, +1, and +4. So those are going to be the 3 zeros I'm also going to need to do the multiplicity of each that I'm going to find from the factors that each of those zeros came from. So let's factor this. Let's do it the other way. Let's do it the drawn out way, especially if you couldn't see on the graph those good crossing spots. So let's see, it has 4 terms with no greatest common factor. There's nothing in common with all 4 terms, which leads me to it is factoring by grouping. So I'm going to put the first 2 terms in a group and the second 2 terms in a group. So we did a lot of this kind of factoring in transitional algebra. For those of you that didn't have transitional algebra, we did do one grouping earlier. So this is a grouping method to factor 4-term polynomials. You look in your first group and pull out the greatest common factor. So I notice they both have x's. The most I can pull out is x squared because this one doesn't have any more than that to pull out. So I'll pull out an x squared. Then I'm going to put in parentheses what is left after I take the x squared out of each of those. Put in here what's left. If I had x cubed, but I pulled out x squared, all I'm left with is x minus, I had an x squared, but I pulled it out. So all I'm left with is that 4. Now, when you're factoring by grouping, you're going to pull what's in common out of the second group also. And what's left in its parentheses should match what was left in this one. When I'm looking at what I'm going to pull out of, I don't see a traditional greatest common factor like I did in that first group, but I do have to pull something out. So it's either going to be, there's 2 options here. I'm either going to pull out positive 1, because I don't need to change anything at all, or I'm going to pull out negative 1 if I just need to change the signs. Now remember, you want these signs to match these signs, which means do they need to change? Yes, they're opposite of what I need them to be. That's what tells me to pull out a negative 1. And when I divide these by negative 1, and put in parentheses what is left, let's see, it changed that to a positive x, and it changed that to a negative 4. Now, the reason that those parentheses have to match is because now they are the greatest common factor. They are what I can pull out. Since I see it in both spots, it's in common. And if I pull out an x minus 4 and put in parentheses what is left. So how do I find out what is left? Well, if you pull out, what do you do with what you pull out? You divide by it. So if I'm dividing by that x minus 4, it's going to cancel it here and there. So what are you going to be left with? This x squared and that minus 1. Now, I notice that this is completely factored because it doesn't have an x squared, but this is not. I can factor this some more. So let's see. Now it's a difference of squares, right? X and x for x squared. How do you multiply to get 1? There's only one way. 1 times 1. 1's a positive, 1's a negative. So now that's completely factored. I'll just drop this other one down. Look at my factors. It's completely factored. When you set those equal to 0 and solve them for x, what would this one give you? Positive 4. What would this one give you? Negative 1. What would this one give you? Positive 1. What did we tell from the graph when we put it in our calculator? That it crossed the x-axis at negative 1, positive 1, and positive 4. So you found it 2 different ways, but this way also, remember you had to answer what was the multiplicity of each of these zeros? Well, once we had it all factored out, what was the exponent of all these? 1s, which means the multiplicity of all of those zeros was 1. They each have a multiplicity of 1. All right, number 6 is a true-false question about multiplicity. So let's remind ourselves, what does I've been saying that word a lot. What does it tell me about each one of the zeros? It tells you whether it's an x-intercept that crosses all the way through the x-axis, or sometimes an x-intercept comes to the x-axis, it touches the x-axis, and then goes the other way. So it's still an x-intercept because it does touch the x-axis. It just doesn't cross through the x-axis. Okay, so those are the 2 types of x-intercepts, and it's the multiplicity that tells you which type that is. So if you are even multiplicity, you're the kind of x-intercept that touches the x-axis and goes the other way, which the word that they use for that, it's not touch and go the other way, it's called tangent to the x-axis. If you are odd multiplicity, that means you cross the x-axis. You're that kind of x-intercept. So there's 2 different kinds. You're either tangent to the x-axis, which means touch it and go the other way, or you cross all the way through it at your x-intercept. Okay? And it comes from the multiplicity. So let's look at the function that it gives us. It says p of x equals x minus 4 to 10th, x plus 3 to the 5th. This says the graph of the function crosses the x-axis at 4, 0. So let's think what this means. So if this is the 0, is at 4, which one of these factors would that have come from? Well, it came from this factor, right? If I set this factor equal to 0 and solved it for x, it would give me x equals 4. That's where this x-intercept came from, which means it's what's the multiplicity of this factor? The multiplicity of that factor is 10, which is an even number, which means it has even multiplicity, which means at this x-intercept, the graph should be tangent to the x-axis. What did the statement say? It said it crossed the x-axis. It doesn't only would cross the x-axis at this x-intercept if this was an odd number right here. Since it's even, it doesn't cross it, it's tangent. So that's why it is false. It's false because that word cross should be tangent to the x-axis, not crossing it. All right, number 7 gives us a function that says f of x equals negative 6x minus x to the 7th. And it wants to know 3 things about this function. It wants to know the maximum number of real zeros, the maximum number of x-intercepts, and the maximum number of turning points. Now, we talked in depth about what made this happen when we were covering this section, and it had to do with the degree of the function, which is the highest exponent. So the degree of this function is 7. The number 7, that is how many real zeros and x-intercepts this could possibly have, the maximum number. Because remember, aren't these two things the same thing? The zeros and the x-intercepts are the same thing. The maximum number of turning points is just whatever the highest exponent is minus 1. Number 8. Sketch the graph of the polynomial function h of x equals x times x minus 2 times x plus 5 times x minus 5. So, two things I can tell right off the bat is what the end behavior of this would be, and I would also be able to tell, since it's in the factored form, what all of its x-intercepts are going to be. So let's talk about the end behavior first. The end behavior comes from whatever the leading term would be. So think about if you multiplied all 4 of these factors together, you would end up at the very end with a polynomial function that starts off with x to the 4th, right? Since there's 4 x's. And it would be positive, wouldn't it? Because none of these x's are negative, which would turn that x to the 4th negative. So I don't have to worry about that. So the leading term would be positive x to the 4th. What does that tell you about the end behavior of this graph? Well, its exponent would be even, which means the end behavior is the same, either both up, both down. And it's positive, which means the end behavior of this graph would both ends be going up. And to be honest with you, I think on that, it's multiple choice. And it didn't print off right, so this problem didn't print off, so I can't hold it up and show it to you right now. But I think there's only one of those multiple choices where the ends of both sides are going up. But let's say there was 2 graphs where the ends of both ends were going up. I can also find all of the x-intercepts from these factors. Let's see, if I set this equal to 0 and solved it for x, it would give me 5. That one would give me negative 5. This one would give me positive 2. And this one would give me 0, which means 2 things are going to happen. The ends of the graph are going to both be going up. And the graph is going to cross through the x-axis at those 4 spots. At 0, 2, negative 5, and positive 5. All right, let's look at number 9. Still wants me to sketch the graph, even though it's multiple choice again, but this time it doesn't give me the factors. So I'm not going to be able to find the x-intercepts unless I do the factoring on my own. But let's see what it does give me. F of x equals 10x to the 3rd minus 6x squared minus 90x plus 54. So it gives me the list of the polynomial functions. So see the difference between this one and the last one. This one, it's like they multiplied all the factors together already. I can still find end behavior, because I do have a leading term of 10x to the third. So let's see, this time my end behavior is going to be odd, which means one side going up and one side going down, which automatically means it's not A, because look at A. What are the ends of its graph doing? They're both going up. But B, C, and D, all three have one up, one down. So now only is it one up, one down, since it's positive. That means the ends are going to start at the bottom, do some stuff in the middle, and end up going up. So which ones are doing that? Starting at the bottom and going up. Well, look at B. B starts at the bottom, does some stuff in the middle, but ends up going up. What is C doing? C starts at the top and goes down throughout the graph. So it's not C. What about D? Again, starts at the bottom and travels up. So it's either B or D. So not C, not A. Now, let's see what else we can find easily without the least amount of work that we need to do. So to find X-intercepts, I have to factor that by grouping, which would take some work. I could do that. What's another determining characteristic of a graph? Is its y-intercept. Where do you find the y-intercept of any graph you're ever going to draw? By replacing all of the x's with zeros. What happens if you replace all these x's with zeros? What would you be left with? What would this turn into? All that would turn into 0, minus all that would turn into 0, minus all that would turn into 0, but then what would you have left out here? That plus 54. So you would have all zeros plus 54. That is your y-intercept. If you replace the x's in your function with zeros, what you have left over is your y-intercept. So remember, we had narrowed this down to B and D. Let's see if we can use the fact that 54 is the y-intercept to figure this out. Look where B. So if this is 250, that means these are going at 50. So 50, 100, 150, 200, 250. So it looks like pretty close to 54 where it crosses the y. Let's look at D. Where does it cross the y-axis? Right there at the origin, which is 0. So that's why the y-intercept, since it was positive 54, was the determining factor that told us which graph that would be without having to do the factoring. Okay? All right, number 10, synthetic division. So it gives us a function, h of x equals x to the fourth plus 4x to the third plus 3x squared minus 6x minus 2. And then it gives us two numbers to see if they are zeros or the function that it wants us to solve by using synthetic division. The first one is -1. Is -1 a 0? Which means if I'm going to use synthetic division, I'm going to need the coefficients of all of those terms. So the coefficient is the number in front of it. So let's see, the coefficient of that one is 1. The coefficient of x to the third is 4. Coefficient of x squared is 3. The coefficient of x is -6. And the constant is -2. Now remember the motions of synthetic division. The first thing you do is drop down that 1. Now you're going to do a bunch of multiplying. Now remember, the motion is this, whatever number's out here, times the number down there, and put your answer under the 4. So let's see, what is -1 times +1? Well, it's -1. And then add that straight down. 4 and -1 is 3. And then do the whole process again. -1 times +3 is -3. If I add that straight down, I get 0. Same thing. -1 times 0. Put your answer there. -1 times 0 is 0. Add it straight down. -6 plus 0 is -6. And last one. -1 times -6 is +6. When I add that straight down, I get 4. So the question says, is -1 a 0 of this function? Well, -1 is only a 0 of the function if, and only if, you do the synthetic division and you're left with a 0 right here. So it doesn't cross through the x-axis at -1. When x is -1, the y is actually 4. So there's where that point would be. So it's not a 0. So -1, not a 0. Now, it wants me to do the same thing and see if +1 is a 0. So I'll just do the same thing, but I'll use +1 this time. So again, drop down to 1. Multiply 1 times 1. Put your answer there, which is 1. Add it straight down. 4 and 1 is 5. Start over. 1 times 5 is +5. Add that straight down. 3 and 5 is 8. Start over. 1 times +8 is +8. When I add this straight down, -6 plus 8 is +2. 1 times 2 gives me 2. And when I add that straight down, -2 plus 2 is 0. So yes, 1 is a 0 of the function. It is an x-intercept. All right, number 11. This is the section where we did a ton of multiplying factors together using FOIL and all that. So remember, we can do both ways. We can start with factors and get zeros, or start with polynomial functions even. So if a whole polynomial function and I needed to find the zeros, I'd have to have the polynomial function, then I'd have to factor it to get my factors in parentheses, and then each factor I would set equal to 0 and solve it for x to find the zeros. Well, now we're going to be going backwards. We're going to be given the zeros, turning the zeros into the factors that they came from, and then multiplying those factors together to get the polynomial function, like on number 11. It says polynomial function of degree 4, which means my leading term is going to be x, some kind of x to the 4th power. So it has -2 is a 0 of multiplicity 3. And 0 is a 0 of multiplicity 1. So what needs to happen first is we need to turn each of these zeros into the factor that they came from. And the factor that they came from is going to be x minus whatever the 0 is. So where did this one come from? If it came from x minus -2, It really came from x plus 2, right? You see what I'm talking about? If I set this equal to 0 and solved it for x, that's where it would give me that negative 2. So there's that 0. What about this one? 0 is a 0, which is the best kind of 0, actually, because it just came from x. Now, what if this one's 0's multiplicity? Its multiplicity is 3. Where does the multiplicity go? What is the multiplicity? Where is it represented? It's this exponent, right? So if it's multiplicity 3, that means this factor is to the third power. 0's multiplicity, which is this factor, is 1. So x to the first is all I need. So here's where the real work comes in. I need to multiply all that together. And what does x plus 2 to the third power mean? X plus 2 times x plus 2 times x plus 2. So once I multiply all that together, then I will multiply whatever that answer is times x. So let's do this foiling. My first, x times x is x squared. X times 2 is 2x. My inner is another 2 times x, which is 2x. My last 2 times 2 is positive 4. And look at these middle two terms. You can put those together since they're both x's. So now I have x squared plus 4x plus 4. So I'm done with these two, which means now I need to drop this one down. So x plus 2. So now what am I doing? I'm multiplying this factor times this one. So I have got to distribute this x squared to both of those. So let's see what that gives me. X squared times x is x to the third. X squared times 2 is 2x squared. So what do you do after you distribute the x squared? Then you move to this next term, this 4x. So you have 4x times x, which is 4x squared. Then you have 4x times positive 2, which is positive 8x. So I'm done with the 4x now. Now the last thing I have to distribute is this 4. So 4 times x is 4x. And 4 times 2 is 8. And then clean it up by combining your like terms. I can put my x squareds together. And I can also put these x's together. So let's see. I'll have x to the third. When I put my x squareds together, I had 2 and 4. So together I had 6x squareds. When I put my x's together, 8 and 4 gave me 12. So 12x plus 8. One last thing, right? So I've done this one times this one times this one. I still need to multiply my answer times x, which is not too bad. So again, I'm just dropping this x down, multiplying it times that. So if I'm distributing an x to all of these terms, all that's going to happen is they're going to gain an x. That's going to turn to x to the fourth. That'll turn to 6x to the third. Let's see, if I distribute an x here, that'll turn to 12x squared. And the last one, if I distribute an x to that 8, I'll have 8x. All right, number 12 says, suppose a polynomial function of degree 4 with rational coefficients has the following given numbers as zeros. It wants me to find the other zeros. So what I would do, since the 2 zeros, it's going to give me 2 zeros, and then it's going to say find the other ones. So let's remember, when you have zeros that are square roots or radicals and ones that are i's, If one of them is a 0, so is the opposite of it. So the 2 zeros that it gives me are negative I and 2 minus the square root of 5. And it wants to find the other zeros. Well, if negative I is a 0, so is positive I. So there's one of the other zeros. If 2 minus the square root of 5 is a 0, then so is 2 plus the square root of 5. So those are your other 2 zeros. So now let's use this information that we know that says if 1 is a 0, so is the opposite of it, to help us with number 13. This one wants us to find the other zeros and then multiply it all together like I did on number 11. So it's saying there's a 0 at the square root of 2, and there's a 0 at 3i. And it wants me to find, first of all, any other zeros. So if this is a 0, so is negative square root of 2. If this is a 0, so is negative 3i. So I'm going to turn those zeros into the factors that they came from, and then I'm going to FOIL all the factors together. So let's see. If this is a 0, what did it come from? X minus the square root of 2. Where did this 0 come from? X plus the square root of 2. This 0 came from x minus 3i. And this 0 came from x plus 3i. Now, we're going to multiply all these together, but we're going to do it in a certain order. Remember, these are conjugates of each other, right? Everything's the same except their sign in the middle. Same goes for these two. Whenever you see conjugates, you want to multiply them together because they clean each other up. Let me show you what I'm talking about. X times x is x squared. My outer, x times the square root of 2, which just gives me positive x square root of 2. Now, look at your inner. What is it? Negative x square root of 2. And then my last, negative square root of 2 times positive square root of 2 gives me negative square root of 4. Here's what I mean by when you multiply conjugates together, they clean each other up. These middle two terms will always cancel. So all I'm left with is this x squared minus, and the square root of 4 is plain old 2, right? So there's that multiplied together. Now let's do the same thing and multiply those together. So those should clean each other up also. So x times x gives me x squared. X times positive 3i gives me positive 3xi. And remember, they're conjugates of each other. So this outer combined with this inner should cancel each other out. And look what we have. Negative 3i times x is negative 3xi. And then your last, negative 3i times positive 3i is negative 9i squared. Again, middle two terms cancel. Let's see what this will give me. I'll break down the x squared. Now, remember, when you get an I squared, it is equal to negative 1. So anytime we have an I squared, we turn it to negative 1, which really means this says negative 9 times negative 1, which is really positive 9. And then I'll have to FOIL these two together. So my first, x squared times x squared is x to the 4th. My outer, X squared times positive 9 is positive 9 x squared. My inner, negative 2 x squared. And my last, negative 2 times positive 9 is negative 18. My middle two terms are both x squared, so I need to put them together. So I've got x to the fourth. Put your x squareds together. I've got 9 and negative 2, so that's positive 7x squared, and then the minus 18. Okay? And I know I'm going to run a little bit long, but I am going to do 14 and 15, so that way on Wednesday, we just have 10 problems. I'm trying to ease up our Wednesday a little bit. All right, 14 says the polynomial function has the given zeros and find the other zeros. So it gives me a function that's x to the third, and it gives you one of the zeros. Okay, we have f of x equals x cubed plus 6x squared minus 7x minus 42. And it tells me that negative 6 is a 0, which means if I perform synthetic division with this negative 6, I should end up with a 0 at the end. But what's going to be important is the numbers that I'm going to be left with at the bottom of that synthetic division are going to be the coefficients of a new polynomial function that is 1 degree less than this one. Since this one's x to the third, what I'm going to be left with is going to be an x squared, which means I'll be able to use my quad program to find the other zeros. So let's use synthetic division again. My coefficients are 1, 6, negative 7, negative 42. So remember, I'm going to get a 0 right here. I know that ahead of time because it already told me that negative 6 was a 0. What I need to know is what these numbers are. So let's drop down this 1. So here I have negative 6 times 1, which gives me negative 6. Add it straight down, which is 0. Multiply again. Negative 6 times 0 is 0. Add that straight down to get negative 7. And the last one, negative 6 times negative 7 is positive 42. And just like I knew was going to happen, when I add that straight down, I do get zeros. But here's what I need. Remember, what you're left with here are the coefficients of a new polynomial. And it's just going to start off 1 degree less than this one. So this is going to actually be 1x squared plus 0x minus 7, which means since it's x squared, now I can put that in my quad program. A is 1, B is 0, C is negative 7. So let's do that real quick in our quad program. Down to quad. Put in your A, B, and C, which are 1, 0, negative 7. Get a crazy decimal. Hit enter again. There's your other two zeros. Positive square root of 7 and negative square root of 7. So positive and negative square root of 7. And then number 15, the last one that we're going to do today is one where we're going to list all the possible zeros of a function. Now, it doesn't mean they all are real zeros. It just means this is the list of the possibilities. of zeros. So if our function is f of x equals 14x to the 6th minus 20x to the 3rd plus 6x squared minus 9x plus 5. When you are finding the list of possible zeros, you need the last term, or coefficient, and the first one. You're going to list the factors of this last one first, actually. So the factors of 5 are 5 and 1, which is great. There's only one way to multiply to get 5. Then list the factors of the leading term. So let's see. How do you multiply to get 14? 14 times 1 and 7 times 2. The way you come up with all of the possible zeros is you put this number over each one of those. And it's the positive and the negative of all that. So let's see. Positive and negative what? 5 over 14. Positive and negative. 5 again over 7. Positive and negative. 5 again, this time over 2. And the last one, 5 again, this time over 1. And 5 over 1 is just 5. So there's that. Now you do the same thing with the other factor. So the 1 over all those. So let's see, positive and negative. 1 over 14. Positive and negative 1, this time over 7. Positive and negative 1, what's the next one? Over 2. And the last one, positive and negative 1 over 1, and 1 over 1 is just 1. So it's whichever one has all of those. 5 over everything, and then 1 over everything. We will start with 16 through 25 on Wednesday. Ooh, that was long. Do you have an 11 o'clock class? Okay, good.
I just got for the day, the last one.
Oh, you have a class before mine? 9 o'clock?